Okay, so finishing up the odd, we're working on the second page of the odd problems from the Kuta software Infinite Algebra 1 free literal equations worksheet. So the first two are still very much like the ones we're going to see on our quiz. Then they're going to get a little hairy, but we might as well go over them and you can see them now. Don't stress it. We will get there. But, you know, the sooner you get exposed, the sooner you can be more comfortable with some crazy looking things. All right, so we have a in the basement. It's in the denominator. It's in this little fraction. But because we know to box in our a and then he's attached to that, we have a b here. We're going to subtract b because that's a positive b attached by addition. And that's the inverse of addition. And we need that b to go away from that side. So z minus b equals m over a. So a is still in the denominator, and that's who we need to get by itself. So we have to get this guy out. So that's m divided by a. And as we've talked about numerous times, what is the inverse of division? Say it loud and proud for those in the back. It's multiplication. So we're going to multiply both sides by a. So I now have a times z minus b equals m, because a is crossed out here. Instead of distributing that all the way through, since we do need it by itself, this is the same thing as a times 4, but our quote-unquote 4 is z minus b. It's that binomial. But it's attached by multiplication. So we know that the inverse of multiplication is division. So we're going to divide by z minus b instead of pushing it all the way through and having to just pull it right back out. So z minus b. So I have a equals m over z minus b. Is a by itself. M, z, and b are all three different terms. They can't be reduced. There's no numbers to reduce. So we are completely finished with this guy. All right, look at number 17. So we're looking to get a by itself. A is attached to c. Make sure you pay attention to that -1 that's right there. That negative makes that c negative as well. So that's -1 times c times a. But we do have a b hanging out just like the prior problem. We're going to move it first. So subtract b because it's a positive b. And so g and b are not like terms. So we just write them as is, g minus b, because that's what we did. And then don't forget our -1, ca. Remember that 1 is just imaginary. We write it so we don't lose it. We need a by itself. So -1 and c is attached to a by multiplication. So we can divide by -1c, -1c. And that's going to put us at g minus b over -1c equals a. Now a is by itself. But our problem is we have a negative in the denominator, and they don't like to leave it that way. So we're going to take that negative. They treat it as if it's hanging out in the front. So this -1 is more or less like -1 out here. And then that gets it out of the denominator, but we have to push it through the top. So multiply it through. So our answer is then going to be a -g plus b all over that positive c equals a. And really, ultimately, you're probably going to have a multiple choice style question for this guy. So just knowing that that is the same as what you had above. So knowing that your negatives in the basement or negatives in the denominator usually will get pushed through the top and switch signs. All right, take a deep breath. Grab a Diet Coke, grab a soda, whatever it is your thing is, your calm juice. Are you ready for this? So it's going to be very doable, but again, you just have to pay attention. This style will probably be a little more advanced than what's going to go on our first quiz, but it will come for us because the EOC, that's what they like to do. Now, I am trying to solve for x, but as I see, there's an x here and an x here. There's two of them. So we're going to get all our x's on one side so we can address that issue first. So we're going to subtract xg from this side, which normally is not a good idea to leave a blank side. But we're going to pull the 4 this way. So that positive 4, as it crosses that great divide, is going to become a -4. So we subtract 4 at the same time. And you can do it in 2 different steps or do it in 1 step. But the end goal is to get all your x's on one side so we can adjust as necessary. So now I have 2x minus xg equals a -4. So I just move this closer to its x partner, and then I move the constant onto the other side by itself because it doesn't have an x with it. Now, here's something that's a little different. It's a throwback to 8th grade math. Hopefully you remember it, maybe even before that, but definitely they should have addressed it in 8th grade math. So at this point, I have an x in both of these, and that's called a greatest common factor or a common factor in both of those two terms. So I can factor that x out, much like in 15 when I said don't push the a through. We're doing the opposite. They push that x through. So we're going to pull that x out, and x times what gives me 2x? x times 2 gives me 2x. Then I have a minus. I pulled out the x. X times what gives me negative xg. This x went to the front, so all that's left over is my g. Now it looks, like I said, much like that number 15 where we had the a and we said don't push it through. We still need x by itself. This is x times 2 minus g. So we're going to divide by 2 minus g on both sides to get rid of the 2 and the g. So the newness in this is that GCF, or just pulling out a common factor. In this case, greatest would probably not be as accurate, but the common factor is at x. So we now have x equals negative 4 over 2 minus g. And is x by itself? It is. Negative 4, 2 minus g makes that 2 and 4 not touchable, because again, if it's a binomial, you can't cross things out, you can't reduce. So if it's one term, just 2g, then you can reduce, but this is 2 terms in a binomial, and binomial meaning the 2 terms within that set of parentheses is how you'll usually see it written, but not always. All right, so we just did it. So your call out being that GCF, making sure you know you can't reduce when you have those a binomial. You can only reduce if it's a single term. All right, on to the next one. These are going to get progressively harder. If your head's going to explode, make it to at least 25, okay? Just get it in your notes. Write it down. We'll do enough of them that eventually they'll make sense. The more you get down, the better, though. Okay, so same game. We're solving for x. We have x and x on the same side, but once in the denominator, we definitely don't want it in the denominator. So we're going to do that first, is get him out of the denominator. So I'm going to multiply both sides by x, multiply both sides by x, and it doesn't touch the top because just like before, even though it's a letter, it just makes the x on the bottom go away on that side. So I now have xg equals x minus c. Sometimes you do have to make a bigger mess or another mess before you can actually get to clean it up. So I need x by itself, but I want to get x over here with this other x and c by himself. Or move this x that way. It's probably even easier, and leave c by itself. So if I have xg and I move this x over, it becomes a negative minus x from both sides minus c. Now I need x by itself. When there's 2 of them in a binomial like that, we have that common factor again, though. So I can pull out an x, that common factor or greatest common factor, whichever terms you really remember. And then I pull that out. So x times g is what gives me xg. And then I need a space holder when I pull that x out and put a 1 right there. Because I would distribute, remember distributive property, x times g gives me xg, x times negative 1 gives me negative x. And now I have that negative c left over. We do want x by itself, and again, this is just like the previous, and number 15, where it's multiplied by, so we're going to divide by g minus 1, and then we have x equals, because these cross out, and that's what we want to see, g minus 1. And that is done because there's not a loose negative in the denominator. Negative c's on the top. It's fine. G's fine on the bottom. That's a binomial at the bottom, so I can't reduce it in any form. I can't really make anything neater and combine like terms. So we are finito. All right. Pause it. Think about it. Take a deep breath. Come back. We have a couple more. 25 is actually really feasible and probably fair, so hang in there. We're going to get to the more of the ones that I need to make sure you can do, but these are good ones. And it's good skills. All right, so we want to solve for A. Again, we have 2 A's. That's not ideal. We need to get our A's on the same side. So I'm going to move my KA this way. So I'm going to subtract KA, and I put a 1 in front of that one. It doesn't really matter. So U equals BA minus KA. Now, hopefully you picked up from the previous problems. BA and KA have a common factor, greatest common factor, A. So I'm going to pull out that A, so that common factor. So I'll pull out an A, and that leaves me with B minus K. Because remember, distribute it. A times B is BA. A times negative K would be that negative KA equals U. And again, it's starting to look just like the ones prior. I need the B minus K off the A. It's attached by multiplication. So I'm going to divide by B minus K. Divide by B minus K. And that gets rid of my B minus K. So I have A equals U over b minus k, or u divided by b minus k. And that b minus k is perfectly fine. So far, we're absolutely perfect. There's nothing that we've messed up on. I think we're great. A is by itself. Looks good to me. All right, so we're good. Done. Now on to 25. You're doing great. Hang in there. So 25, we're trying to get A by itself. So we need this bugger by himself. He has all kind of stuff tied up around it. Let's do each one by itself. So we're going to subtract 3b, subtract 3b. So I now have u minus 3b equals negative 2a plus 2. Again, you're trying to get 2a by itself. So we're checking to see if there's anything on the outside before we start actually dividing. So we do need to subtract that 2. That 2 can't combine with a u. It cannot combine with a 3 because those are not like terms. So you got to make sure you're paying really close attention. You can't combine things that don't match. And then I have equals negative 2a. So we're just writing down what happened. Now that negative 2 is attached by multiplication, and the inverse of multiplication is division. So we're going to divide by 2. These 2's go away. So I have a equals u minus 3b minus 2 all over negative 2. Now, again, remember, negatives don't usually stay down here. They treat it like a negative 1 on the outside, get rid of it, and distribute it through the top, which just changes your symbols all the way through. So we're going to have a negative u plus 3b plus 2 all over that positive 2 for our final answer. Number 27, he's ugly. You see those 2 A's, right? So I bet you guess you know what we're going to do with that. We're going to find a common factor in this side because the A's are on the same side. G's hanging out by himself. No big deal. So we're going to pull out that A as a common factor, and then we're going to write what we have left. So 4C times A is what gives me 4CA. And then 3B times A gives me 3BA. And then I have G equals. Now, again, multiplication, A times. So we're going to divide by 4C minus 3B. 4C minus 3B. And this side cleans up. And so A is going to equal G all over 4C minus 3B. A is by itself. There's not an odd negative in the bottom that we need to distribute through or work on. It is perfect. And last but not least, number 29. We're solving for x. It's almost a relief to see this problem, in my opinion. I don't know how you feel about it at this point. And all that's attached to that x is a 4 by multiplication. So I'm going to undo it by dividing by 4 on both sides. And then I end up with x equals negative 4r plus 2d all over 4. Now, this is a perfect answer for me where we are right now because I'm not going to be testing you as much on your GCFs and your common factors, but it is not the perfect answer by Kuta. So negative 4 and 2, again, so looking for a common factor up here at the top, I can factor out a 2 because 2 goes into negative 4 and 2 goes into 2. So I'm going to take out a 2, and I end up with a negative 2r, because again, distributive property, negative 2 times 2 gives me negative 4r, plus 1 times 2 gives me 2, and then d all over 4. But I can reduce again because remember, this is a binomial. You can't cross through here. But when it's multiplication, you can reduce it. And it becomes negative 2r plus d over 2 goes into there 1, 2 goes into there 2 times, over 2. And then you can't reduce any more. So these last couple ones, I will say, were probably a little more intense for our first day. But I know you've got it. And as I've said before, the more you work, the better you're going to get. The more you write down in your notebook, the better you'll be prepared for our midterm. So just hang in there, ask questions, send me questions, and I'll see you during live class, guys.